Hello everyone and welcome to the lecture on Amazon Managed Streaming for Apache Kafka, also known as Amazon MSK. So this lecture will contain all these topics. What is Amazon MSK? Architecture of Amazon MSK, K-Raft mode, tiered storage features and benefits, MSK serverless. What is MSK Connect? So what is Amazon MSK? Amazon Managed Streaming for Apache Kafka is a fully managed service that enables you to build and run applications using Apache Kafka for processing streaming data. This means AWS handles the complexities of maintaining and operating Kafka clusters, allowing you to focus on your applications. Amazon MSK is designed specifically for handling streaming data. This makes it ideal for applications that need to process continuous flow of information in real time, such as log analytics, event-driven applications, or real-time dashboards. Amazon MSK manages all the control plane operations for you. This includes creating new Kafka clusters, updating existing ones, and deleting clusters when they are no longer needed. This automation significantly reduces the operational overhead for users. While Amazon MSK manages the infrastructure, it still allows you to use Apache Kafka's native data plane operations. This means you can produce and consume data using familiar Kafka APIs and tools, giving you full control over your data processing logic. Amazon MSK uses open source versions of Apache Kafka. This ensures compatibility with the broader Kafka ecosystem and allows you to leverage the latest features and improvements from the open source community. Because Amazon MSK runs open source Kafka, it supports existing applications, tooling, and plugins from both partners and the Apache Kafka community. This means you can migrate existing Kafka-based applications to Amazon MSK without needing to change your application logic, saving time and reducing migration risks. Architecture of Amazon MSK. When creating an Amazon MSK cluster, you specify the number of broker nodes for each availability zone with a minimum of one broker per zone. Each availability zone has its own virtual private cloud VPC subnet, ensuring high availability and fault tolerance. Amazon MSK automatically creates Apache Zookeeper nodes for you. Zookeeper is an open source server that provides highly reliable distributed coordination for the Kafka cluster, managing configuration information and synchronization across the cluster. K-Raft, known as Kafka Raft, is an alternative to Zookeeper developed by the Apache Kafka community. In K-Raft mode, cluster metadata is managed within the Kafka cluster itself rather than in separate Zookeeper nodes. K-Raft controllers are included at no additional cost and require no extra setup or management. Amazon MSK supports Apache Kafka data plane operations, allowing you to create topics, produce data to topics, and consume data from topics using standard Kafka APIs and tools. This enables seamless integration with existing Kafka-based applications. You can manage your MSK clusters using AWS Management Console, AWS Command Line Interface, or SDK APIs. These tools allows you to perform control plane operations such as creating or deleting clusters, listing clusters, viewing cluster properties, and updating the number and type of brokers. Amazon MSK includes built-in fault tolerance features. It automatically detects and recovers from common failure scenarios, ensuring minimal impact on your applications. When a broker failure is detected, MSK mitigates the issue or replaces the unhealthy broker, often reusing storage to minimize data replication. This process limits downtime and allows your applications to continue operations with the same broker IP address after recovery. Okay, this is a comparison of K-Raft mode or the Zookeeper. So Zookeeper is the older technology which was there for a very long time. then there is a new way to control the Kafka cluster and to maintain the metadata. So let's talk about KRaft mode. So Amazon MSK introduced support for KRaft, which is Apache Kafka Raft, in Kafka version 3.7.x onwards. The Apache Kafka community developed KRaft to replace Apache Zookeeper for metadata management in Apache Kafka clusters. In KRaft mode, cluster metadata is propagated within a group of Kafka controllers which are part of the Kafka cluster instead of across Zookeeper nodes. KRaft controllers are included at no additional cost to you and require no additional setup or management from you. So earlier Zookeeper was used for metadata and cluster coordination, which was a separate technology for distributed applications. So the Apache Kafka community felt that there is a requirement to build this technology or this mechanism right into Kafka, and then they came up with KRaft, which is now part of Kafka cluster itself, and it is controlled by Kafka controllers, like KRaft controllers we call. Availability. KRaft mode is only available for new clusters. You cannot switch metadata modes once the cluster is created. Cluster creation. On the MSK console, you can create a KRaft based cluster by choosing Kafka version 3.7.x onwards and selecting the KRaft checkbox in the cluster creation window. Partition capacity. The number of partitions per broker is the same on KRaft and Zookeeper based clusters. However, KRaft allows you to host more partitions per cluster by provisioning more brokers in a cluster. Metadata storage and access control. In KRaft mode, your cluster's metadata is stored on KRaft controllers within Kafka and not external Zookeeper nodes. Therefore, you don't need to control access to controller nodes separately as you do with Zookeeper nodes. Okay, this is now I will talk about there is a feature called tiered storage in Amazon MSK. So tiered storage is a low cost storage tier for MSK that scales to virtually unlimited storage, making it cost effective to build streaming data applications. You can create an Amazon MSK cluster configured with tiered storage that balances performance and cost, optimizing your streaming data infrastructure. Amazon MSK stores streaming data in a performance optimized primary storage tier until it reaches the Apache Kafka topic retention limits. Then it automatically moves data into the new low cost storage tier. The system automatically manages the movement of data between tiers based on the retention limits, reducing manual intervention and management overhead. When your application starts reading data from the tiered storage, you can expect an increase in read latency for the first few bytes. As you start reading the remaining data sequentially from the low cost tier, you can expect latencies that are similar to the primary storage tier. You don't need to provision any storage for the low cost tiered storage or manage the infrastructure. You can store any amount of data and pay only for what you use, making it a flexible and cost-effective solution. Okay, next I will talk about some of the benefits of using tiered storage. So actually this is a common problem in like if you set up your own Apache Kafka cluster, like you have to move the storage from hot or something like which is very active to the lower mode. So let's say data is coming in, so it will be there in the performance tier, and then it will go to tiered storage, which is a low cost storage tier. So Amazon MSK tries to handle this. So let's see the benefits. You can scale to virtually unlimited storage. You don't have to guess how to scale your Apache Kafka infrastructure, providing flexibility for growing data needs. You can retain data longer in your Apache Kafka topics or increase your topic storage without the need to increase the number of brokers. This allows for extended historical data analysis without additional infrastructure cost. It provides a longer duration safety buffer to handle unexpected delays in processing. This feature enhances system resilience and helps manage unforeseen processing issues. You can reprocess old data in its exact production order with your existing stream processing code and Kafka APIs. This maintains data integrity and allows for consistent historical analysis. Partitions rebalance faster because data on secondary storage tier does not require replication across broker disks. This improves system performance during scaling or maintenance operations. Data between brokers and the tiered storage moves within the VPC and does not travel through the internet, ensuring data security and reducing potential latency. A client machine can use the same process to connect to new clusters with tiered storage enabled as it does to connect to a cluster without tiered storage enabled, and this ensures backward compatibility and ease of adoption. Okay, now let's see MSK serverless, which is used for so there is you have the default option, which is managed MSK, but Amazon introduced also this technology called serverless. Amazon managed streaming Kafka, but this is now there is a serverless version also available. MSK serverless is a cluster type for Amazon MSK that allows you to run Apache Kafka without managing or scaling cluster capacity. It handles the provisioning and scaling of capacity automatically, including managing partitions in your topics. This feature enables you to focus on streaming data without worrying about right sizing or scaling clusters. The service automatically scales capacity up and down based on your application needs. This is particularly useful for applications that require on-demand streaming capacity with automatic scaling. So if you want more control, you can go with MSK, the regular managed version. But if you want to not at all worry about, you can go with serverless version. And MSK serverless offers a throughput-based pricing model, meaning you only pay for what you use. This can lead to cost savings, especially for applications with variable on or unpredictable workloads. So MSK serverless is fully compatible with Apache Kafka, and this means you can use any compatible client applications to produce and consume data, allowing for seamless integration with existing Kafka-based systems. And some key integrations of MSK serverless. So MSK serverless integrates with AWS services, and which are AWS Private Link, which provides private connectivity, enhancing security by allowing you to access MSK serverless without exposing your traffic to the public internet. Then AWS Identity and Access Management, which enables authentication and authorization for both Java and non-Java languages, helping you secure access to your Kafka clusters. AWS Glue Schema Registry, which offers schema management capabilities, allowing you to maintain consistency in your data structures across different applications and over time. Then Amazon Managed Service for Apache Flink enables Apache Flink based stream processing, allowing you to analyze and act on your streaming data in real time. And AWS Lambda, which facilitates event processing, allowing you to trigger serverless functions based on events in your Kafka streams. Okay, then we have MSK Connect, which is a technology which I'll talk about, which is for streamlining Kafka data flow, which is basically a connector technology. So you can write your own producers and consumers in Java or other languages, but this is a framework to connect, as the name suggests, to connect multiple source and sinks using something called out of the box. There are lot of connectors available and utilizing this. So MSK Connect is a feature of Amazon MSK that simplifies the process of streaming data to and from Apache Kafka clusters for developers. It provides a user-friendly way to manage data flow in Kafka-based systems. MSK Connect is built on Kafka Connect 2.7.1, which is an open source framework. This framework enables connections between Apache Kafka clusters and external systems such as databases, search indexes, and file systems. With MSK Connect, you can deploy fully managed connectors that are built for Kafka Connect. These connectors can move data into or pull data from popular data stores like Amazon S3, Amazon Open Source Service, and others, which will simplify data integration tasks. Source connectors are used to import data from external systems into your Kafka topics. This allows you to bring data from various sources into your Kafka ecosystem for processing and analysis. Sync connectors enables you to export data from your Kafka topics to external systems, and this facilitates the distribution of processed data to various destinations or storage systems. MSK Connect supports connectors developed by third parties. For example, you can use Debezium for streaming change logs from databases into an Apache Kafka cluster. Existing connectors can be deployed without any code changes, providing flexibility and extensibility. Connectors in MSK Connect automatically scale to adjust for changes in load. This ensures optimal performance as your data volume fluctuates. Additionally, you only pay for the resources you use, making it cost effective. MSK Connect supports connectors for any Apache Kafka cluster that has connectivity to an Amazon VPC. This includes both MSK clusters and independently hosted Apache Kafka clusters, providing versatility in deployment options. MSK Connect continuously monitors connector health and delivery state. It also handles patching and management of the underlying hardware. This reduces the operational burden on your team and ensures the reliability of your data streaming processes. And that's all. Thanks for watching.